Welcome to the lecture series of C and C++ programming under EPG Pathshala. Today we will start with module data types. As everybody knows, any computer program will consist of three steps. It takes the input data, it processes it and it produces the output data. Input data or the information is stored inside the memory. The smallest unit where we can store the information is basically called as bytes. For any programming language, we require to store a data. This particular data will be stored inside the memory. Each and every data will have two things. One is a data type and second is a permissible set of values. Data type basically gives the type of data that we can store inside the variable and the range of data that can be stored inside the variable. So there are two things that is given by the data type. One is the memory location and second the data that can be stored inside the memory location. For any programming language, a rich set of data types are provided. In C++, there are three basic types of data that is provided. Those three main types are built-in data types, user-defined data types and derived data types. In this particular module, we will write some small programs for each and every data type and we will see in detail what all data types are supported in C++. So, let us start with the module. In computer programming, information is stored in computer memory with different data types. It is must to know what is to be stored in a computer memory, whether it is a simple number, a letter or a very large number. Since computer memory is organized in bytes and these variables are of different with the information, therefore there is necessity for an association of a data type. The minimum amount of memory in computer is a byte that can store a small amount of data and managed easily. Every variable is declared with two entities, its type and its name. There are several data types available in C++. So, let us start with our objective of this particular module. Get familiar with identifiers, get familiar with constants, study about data types, study about symbolic constants, get familiar with type compatibility. Now, let us see what are the identifiers. They are mainly referring to the names of the variables, arrays, functions and classes etc., which are created by the programmer. They are the essential requirement of any language. Each language follows some predefined rules for naming the identifiers. The rules are common to C and C++ language and they are: the alphabetic characters, digits and underscores are only permitted. The name should not start with a digit. Uppercase letters and lowercase letters are different. A variable name cannot be a keyword in C++ language. Next, we will see what is constant. Constant refer to a fixed values that do not alter during the execution of the program. C++ supports various types of literal constants which consist of characters, integers, floating point numbers and strings. In C++, consist of new type of wide characters literal which begin with the character L, which is mainly used for character sets which cannot fit a character into a single byte. C++ language identifies all the backslash character constants that are available in C language. We will see some examples of different constants. Here 100 is an integer constant, 10.50 is a floating point integer constant, welcome is a string constant, character A is a character constant, L in single quotes A is a wide character constant. A data type decides the type and the operations that can be performed on the data. C++ provides a variety of data types and each data type is represented differently inside the memory of the computer. The data types are those keywords which confirm what type of variables are going to be declared. Based on the data type of a variable, the operating system allocates memory and decides what can be stored in the reserved memory. The various data types provided by C++ are built-in data types, derived data types and user-defined data types. Built-in data types can be further divided into three, that is integral type, floating type and void type. Integral type can further be divided as integer and character. Floating point can be divided into two subclasses, float and double. Derived data types are arrays, functions, pointers and references, and user defined data types in C++ are structure, union, class and enumeration. The basic data type that are provided by C++ are integral data type, floating point data type and void data type. The two more data types that are introduced by C++ are Boolean data type and wchar_t data type. The built-in data types that are provided by C++ are integer, floating point and void data type. The integral and floating point data types can be preceded by many type modifiers. These modifiers are known as type qualifiers. The type qualifiers are the keywords that modify either the size or the range or both of the data types. The different modifiers that can be applied to character data type are signed and unsigned, whereas the modifiers that can be applied to the integer data type are short, long, signed and unsigned, and the only modifier that can be applied to a double data type is long. The data type representation is machine dependent or machine specific. Now let us see the character data type. The characters refer to the alphabets, numbers and other characters such as symbols, opening braces, @sign, hash, etc. These are defined in ASCII character set. The character data type occupies 1 byte of memory, that is, it can hold only one character at a time. The modifiers that come first for character data type are signed and unsigned. The character is a keyword which is used to represent the character data type in C++. When more than one variable is to be declared in the same line, then it is must to use a comma as a delimiter. When the character variables are to be defined in different lines, the syntax is character char space variable name semicolon. Example, char C1 semicolon, char C2 semicolon. The various character data types and modifiers along with their size and range are represented in the following table. As you can see in the table, the character takes 1 byte of memory, signed character takes 1 byte of memory and unsigned character takes 1 byte of memory. But the range of these particular three types is different, as you can see in the slide. Now let us see the simple program to see the usage of the character data type. The program starts with #include iostream using namespace std, integer main. Here we are declaring the character as character C and we are giving the initial value as alphabet capital A. We are displaying back the value of C on the screen as C out, character is the value of C, end L, and return 1, our program ends. When the following code is executed, it will produce the result as character is and the value capital A. Now let us see the integer data type. The integers refers to positive and negative values. The integer data type occupies 2 bytes of memory. The modifiers that can come first for integer data type are short, long, signed and unsigned. The integer is a keyword which is used to represent the integer data types in C++. When more than one variable is to be declared in the same line, then it must use a comma as a delimiter. When the integer variables are to be defined in different lines, it is a must that they must be preceded by the type. The syntax is integer space variable name. Example, int integer I1 semicolon integer I2. The various integer data types with their size and range can be represented in a table as shown in the slide. The different types are given, their sizes, how much memory they can occupy in bytes, and the different range of values that can be represented by a specific data type. Now let us see a simple program for the usage of integer data type. It starts with #include iostream using namespace std, integer main. Here we are declaring the variable integer I1, we are assigning the initial value as I1 equal to 10. We are displaying back value on the screen as C out integer is the value of I1 and end L, return 1 and the end of the main program. When the above code is compiled and executed, it produces the result as integer is 10. A floating point data type is used to store real numbers. The floating point data type can be used to represent the values between integers, and they can represent greater range of values. This data type consists of float and double data types. First we will start with the float. The variables of float data type consist of values which consist of a decimal value in it. The values will exist in positive and negative forms. The float is a keyword which is used to represent the floating point data type in C++. The float data type occupies 4 bytes of memory. When more than one variable is to be declared in a same line, then it must use a comma as a delimiter. When the float data type variables are to be defined in different lines, it is must that they should be preceded by the type. The syntax is float space variable name semicolon. Example, float space f1, float space f2. Now let us see the program to see the usage of the float data type. It will start with hash include iostream. Using namespace std, we will start with the main function. We will declare the variable as float f1 equal to the value 12.5. We will display this value on the screen as cout value of f1 is a string and the value of f1 variable f1 end l return 1 and the main program ends. When the above code is compiled and executed, it produces the result as value of f1 is 12.5. The next category of floating point is double. The variables of double type consist of values which consist of decimal value in it. The values will exist in positive and negative forms. The modifier that can come first for double data type is long. The double is a keyword which is used to represent the double data type in C++. The double data type occupies 8 bytes of memory. Double data type is the ideal floating point type for most of scientific and engineering calculations. It stores floating point numbers with much larger range and accuracy. The syntax is double space variable name semicolon. Example, double space d1 semicolon, double space d2 semicolon. The various floating point data types with their size and range are represented in a following table. The table shows the type, the size, the range of permissible values for that particular data type and the digit of precision for that particular data type. Now let us see the simple program to see the usage of double data type. Hash include iostream. Using namespace std, integer main. Here we are declaring the variable double pi with the initial value as 3.141521. We will display the value of pi on the screen as cout value of pi is the variable value pi and end l return 1 and our program ends. When the above code is compiled and executed, it produces the following result as value of pi is 3.14. The next data type is a void data type. The void data type is an empty type. Since no memory is allocated for void data type, therefore it cannot store anything. The void data type can be used in 3 different ways. They are: the first one, it can be used for the return type for a function which indicates that it does not return any value to the function from where it is called. Example, the return type void, name of the function as display, and it takes the argument as character star name. Opening braces, cout hello and the value of the name on the screen, closing bracket. In the above code, when the function is executed, it displays only the name, but it does not return any value to the function from where it is called. Therefore, the return type is void. The second void data type is, it can be used for denoting an empty parameter list to a function. It can be also used as an argument for a function. When void is found in function heading, it indicates that the function does not take any arguments. Example, the return type is integer, name of the function is f1 and the argument list is void. From this particular function, we are returning 1 and the function ends. In the above code, the f1 is a function which does not require any argument, but it returns an integer value from where the function is called. The third usage of void data type is, it can also be used as a return data type and it can also be used as an argument to a function. Now we will see the program to display a message using void as return data type and void as an argument list. Hash include iostream. Using namespace std, void the function fun and the argument list is void. Here you can see the return data type is void and the argument list is void. Now we will start with the main function integer main. We are calling the function fun and we are returning 0 from the main program. Main function ends. Now start with the function void fun void, where inside the function we are displaying the message cout hello and the function ends. When the above code is compiled and executed, it produces the following result as hello. The two new built-in data types that are introduced in C++ language are boolean and wchar_t. Now let us see the boolean data type. The bool data type can hold only boolean values, that is either true or false, where true represents 1 and false represents 0. It requires only 1 bit of storage. However, it is stored as an integer in the memory. The bool data type is most commonly used for conveying the results of logical operations performed on the data. It is also used as a return type of a function indicating the success or the failure of the function. Syntax: bool variable name semicolon. Example: bool flag equal to 1. Now let us see a program to implement the usage of the bool data type. Hash include IOStream using namespace std. We will start with the main program. Integer main, we are displaying two boolean variables, bool b1 equal to 1, bool b2 equal to 0, and we are displaying the values as cout, the status is the value of b1, cout, value of b2 is the value of b2, and the main program ends. When the above code is compiled and executed, it produces the result as status is true and the second is value of b2 is false. Now let us see the wchar_t data type. The wchar_t data type is used to display wide characters that will occupy 16 bits of data. This data type occupies 2 or 4 bytes. The wchar_t data type is used mostly when international languages like Japanese are used. The wide characters are used to hold large character sets associated with some non-English language. Syntax: wchar_t variable name semicolon. Example: wchar_t wc semicolon. Let us see the program to implement the usage of the wide character data type. We will start with the program. Hash include IOStream, integer main. We will declare the variable as wchar_t w. We are giving the initial value as w equal to L capital A. Cout wide character value is the value of w, and cout the size of wide character is size of w, and our program ends. When the above code is compiled and executed, it produces the result as wide character value is 65 and size of the wide character is 2. Now let us write a program to print the size of various built-in data types. So we will understand what is the memory requirement for a particular machine. Hash include IOStream using namespace std. We will start with the main function main. Now we are displaying the different sizes: size of character, size of int, size of short int, long int, float, double, and wchar_t, and our program ends. When the above code is compiled and executed, it will display the following result as size of character is 1, size of integer is 4, size of short int is 2, the long integer is 4, size of float is 4, size of double is 8, and size of wchar_t as 4. Here please note that the size of the variables may be different because it is purely depend on the compiler and the computer that is being used. Now let us see the derived data types in C++. The data types that are derived from the built-in data types are known as derived data types. The derived data types that are offered by C++ are arrays, functions, references, and pointers. An array is a set of collection of homogeneous elements of the similar data type that are referred to by the same name. Each element of an array is stored in memory locations indexed from 0 through n number of its elements. The lowest index will be the first element and the highest index will be the last element of the array. The subscript of the index value indicates the position of an element in an array. Like a regular variable, the array must be declared before it is used. The syntax is the type, array name, and in square brackets the array size. In the above syntax, the type defines the data type, Array name defines the unique name of the array, and the array size field indicates within the brackets represents the number of elements the array is going to hold. It is a must that it should be a constant value, since arrays are blocks of non-dynamic memory whose size must be determined before the execution. If the size of the array is not specified, then the compiler will automatically calculate the size of the array. Now let us see a simple program for the use of array. Hash include IOStream using namespace std. We will start with the main function. Here we are declaring the array as int ar3. The name of the array is ar and the size of the array is 3. Now we are giving the values, 3 values to the array. Because the array will start with 0, we will start giving the value with 0. R0 equal to 100, R of 1 equal to 200, R of 2 equal to 300. Now we will display back the values on the screen. The array values are cout R of 0, cout R of 1, cout R of 2, return 0. When the above code is compiled and executed, it will produce the following result as 100, 200, 300 on a new line. Because after every cout statement we had used /n, so the value will be displayed on a new line. Now let us start with the function, which is treated as a derived data type in C++. A function is a self-contained program segment that carries out a specific well-defined task. In C++, every program contains one or more functions which can be invoked from other parts of the program if required. The main reason for using it is to structure the programming by creating functions for repetitive tasks. In C++, it is possible to use the same function name with various definitions, which is possible with the help of the function overloading, which we will see in the next modules. The syntax is return type, the function name and the arguments if any, and then opening and closing bracket, inside that the body of the function. For example, void display opening and closing bracket void, and here we are displaying the message welcome to the arrays in C++. Let us see the simple program for the use of the function. Hash include IOStream using namespace std. We are declaring the function as return type void, display, the argument list is void. Integer main, we are calling the function display and we are returning 0 from the function. Now we will start with the function definition. Void display, the argument list is void. We are displaying the message welcome to arrays in C++ and the function ends. When the above code is compiled and executed, it will display the result as welcome to arrays in C++. Now let us see a pointer as a derived data type. A pointer is a variable that can store the memory address of another variable. Pointers allow it to use the memory dynamically. With the help of pointers, memory can be allocated or deallocated to the variables at runtime, thus making a program more efficient. Pointers are widely used in C++ for memory management or for achieving polymorphism. A pointer is declared like a normal variable, but it is always preceded by the star operator. Syntax: data type star variable name semicolon. Example: integer star IP, float star FP. Now let us see the program for the usage of pointers. Here we will start with the main function. Integer is declared with the value 2. The pointer is declared as star IP1. We are displaying the address of x as &I end L. Now we are giving the address to the pointer as IP1 equal to address of I. We are displaying the message as value of x equal to star IP1 end L, return 0. When the above code is compiled and executed, it produces the result as the address of x is some hexadecimal number and the value of x is equal to 2. Void pointers or generic pointers. When a variable is declared as a pointer to a void data type, then it is known as a generic pointer or a void pointer. The void pointer or the generic pointer is a special type of pointer that can be pointed at objects of any data type. A void pointer is declared like a normal pointer by using the void keyword as the pointer's type. In general, the pointers that are defined using specific data type cannot hold the address of the some other type of variable. But this problem can be solved by using the void pointer in C++ because it do not have any type associated with them and can hold the address of any type of variable. A generic pointer or a void pointer can be allocated the pointer value to any basic data type, but it is not possible to dereference it. Syntax: void star pointer name semicolon. Example: void star VP float star FP. Now we are assigning VP equal to %FP, the address of float pointer FP. Now let us see a simple program for the usage of void pointer. We will start with the main function. I is declared as integer, C is declared as a character, star data is a pointer of type void, I value is 6, C value is A, and now we are giving the value to the void pointer data equal to %I. Now we are displaying back the value of integer I as C out data pointing to integer is star in bracket integer star data and L. Now the data is given the address of C. We are displaying the value on the screen as data pointing to a character is star char star data return 0. Now when the above code is compiled and executed, it will produce the result as data pointing to integer is 6 and data pointing to character is A. As you can notice here, the same pointer void data is used to point to a integer data type as well as a character data type. Reference: a reference is an alternative name for a variable. It provides an alias for a previously defined variable. A variable and its reference can be used interchangeably in a program as both refer to the same memory location. Therefore, the changes made to any one of them are reflected in the other. The referencing operator ampersand is used to define the reference variable. Syntax: data type ampersand reference variable equal to variable name semicolon. Example: integer n1 equal to 100, integer ampersand n2 equal to n1. Now we will see the program for the usage of reference variables. We will start with the program. First one will be hash include iostream. Second, using namespace std. Now we will start with our main function, integer main opening and closing bracket. Now we will declare different variables which are required in the program. The first one will be integer I, second one will be double d. Now we will declare two reference variables, one for integer and second for double. Now the reference variables will be declared as integer ampersand I1 equal to I, second one double ampersand d1 equal to d. Here we are having two reference variables where no separate memory will be allocated. It will be assigned the same memory of I and d variables. Now let us assign the value to variable I equal to 10. Now we will display the values of I and the reference variable I1. So we will display both the values using the cout statement. Cout the value of the variable I is, second cout the value of the reference variable ampersand I1 is. Now we will give the value to the double variable d equal to 10.5. Now we will display the double variable d and the reference variable d1. So our statements will be cout the value of d is and cout the value of the reference variable d1 is, and our program will end. When we execute this particular program, we will get the same values for I1 and I, that is 10, and we will get the same values for d and d1, that is 10.5. The user defined data types that are supported in C++ are structures, unions, classes and enumeration. Let us see each one of them. First we will see structures. The structures in C++ are a collection of heterogeneous data type variables which are grouped under one name. The structures in C++ can be declared with the keyword struct. By default, all the members of a structures are public, but it is possible to declare private members in a function. Struct type name, opening curly bracket, the data type, name 1 and the length, and end of the structure with variable list. Now let us see a simple program for the usage of structure. The structure is declared for the employee with two fields, employee number and employee salary. In main function, we are declaring the variable of employee structure as emp1 and we are assigning the initial values in a curly bracket as 23 and 12,000. Now 23 will be assigned to the employee number and 12,000 will be assigned to EMP salary. Now we will display the values on the screen as employee number is equal to employee 1 dot employee number and employee salary will be employee 1 dot employee salary, return 0. When the above code is compiled and executed, it will produce the result as employee number 23 and employee salary 12,000. Next type is unions. The union in C++ is a user defined data type which allows some portion of the memory location to be shared by two or different variables, usually of different data type. Since all of the union variables refer to the same memory location, therefore the change of the value of one element will affect the value of the all of them. Syntax union, union data type, and inside that the data type and the variable name for the union, and union ends. Example, union employee, opening curly bracket, integer num, float salary, closing curly bracket. Now let us see a simple program for the usage of union. Here the union is declared as union employee and the two fields are integer num and float salary. Here only one of the value will be valid for any particular variable. Integer main, here the employee is declared as employee E1, E1 dot number is equal to 2. C out, we are displaying back the employee number as E1 dot number and the salary is E1 dot salary. Now E1 dot salary is equal to 2000. C out employee number E1 dot number, salary is E1 dot salary, return 0. When the above code is compiled and executed, it will produce the result as employee number 2 and the employee salary any garbage value. Second, employee number will be any garbage value and the salary is 2000. As you can see here, only one variable or only one value will be valid for the enum, either the number or the salary. Anonymous union. It does not have any tag name. The element of anonymous union can be accessed without using the tag name. Syntax union, opening bracket, and the variable will be there for that particular union, closing bracket, semicolon. Example, union in bracket, integer employee number, float salary, closing bracket. Classes. A class is one of the most important feature of C++. Since object-oriented programming is usually implemented through the use of classes, C++ offers a new user-defined data type known as class, which structure the basis of object-oriented programming. A class is a collection of data and functions under one reference name which tries to bind the data and its associated functions together. All the elements of a class are private by default, but the elements can be declared as public or protected. Classes are declared using the keyword class. Once a class has been declared, its object can be easily created. An object is nothing but the instance of a class. Syntax, the class name, opening bracket, access specifier colon, data members and member functions, the class end, semicolon. Let us see a simple program for the usage of the class. Here the class test is declared as the private data members, integer number, and the public member functions, set number and show function. Set number will give the value to the number as n and void show will display back the value of the number as number is the value of the number. Let us start with the main function. We are declaring the objects of the class test as test xy. Now we will call the member function x dot set number, second y dot set number 1, 2, 4, 5, second x dot show and y dot show, return 0, end of the main program. When the above code is compiled and executed, it will produce the result as number is 100 and number is 1, 2, 4, 5. Enumeration. The enum is a keyword which is used to declare enumerated data type which consists of a set of named values. It can be used to assign names to integer constants. The values of enumerated data type can be used in indexing expressions. The main use of enumerated data type is that the programmer can declare the new data type and define the variable of these data types that can hold. Syntax enum type name, in curly bracket enumeration list. Example, enum shape, in curly bracket circle, square, triangle. Now here the shape is a enumerated variable which can take only these three values: circle, square and triangle. Enum color, red, blue, green, yellow. Here the color values which are allowed for the color variable are red, blue, green and yellow. C++ also permits the creation of the anonymous enum, that is enum with the tag name. So, example is enum in bracket of and on. Here the tag name or the variable name is not present. Now let us see the program for the usage of enumerated data type. Here the main function is declared enum no, yes. Here no tag name is given and the values of enum are no or yes. Integer flag 1 is equal to no, integer flag 2 is equal to yes. C out flag 1 is the value of flag 1, flag 2 is the value of flag 2, return 0. When the above code is compiled and executed, it will produce the result as flag 1 is 0 and flag 2 is 1. Now here we have seen all the data types in C++. Now let us see a simple program to implement the usage of different data types and their sizes. Here we will start with the main program. We are declaring the variables of type integer, float, character, long, integer, short, double, float and wcarity. So different values, initial values are given to this particular variables. Now we will display the value of the messages as the positive integer number is A, the positive float number is B and so on and so forth. When the above program is compiled and executed, it will display the values as positive integer number 3000, positive float number, the float number value and so on and so forth till the last wide character value 66. Symbolic constants. The symbolic constants can be executed in two ways in C++ language. They are using the qualifier const. Any value that is declared as const cannot be modified by a program, but in C++ it is possible to use const in a constant expression. The constant keyword allows creating typed constants instead of using hash define, which is used to create constants that have no type information. Example, const integer size equal to 10, char name in bracket size. The name constants are just like variable except that their values cannot be changed. It is must in C++ to initialize a const. By default, a const in C++ is local to the file where it is declared, but it can be made global by using the qualifier extern. Example, extern const int maximum marks equal to 100 semicolon. The second way of defining constants is defining a set of integer constant with the help of enum keyword. Example, enum in curly bracket a, b, c. In the above example, a, b, c is defined as integer constants whose values will be 0, 1 and 2 respectively. The above line of code is equivalent to const int a equal to 0, const int b equal to 1, const int c equal to 2. It is possible to assign the values explicitly to a, b and c. Example, enum in curly bracket a equal to 10, b equal to 20, c equal to 30, curly brackets end. The values in the above line of code are treated as integer values. Type compatibility. C++ language is stringent in type compatibility compared to that of C language. The data types such as integer, short integer and long integer are treated as different data types. It is must that they must be cast when their values are to be assigned to another one. The character, signed integer character and unsigned character are also treated as different data types, even though each of them occupies 1 byte of storage. In C++, data types of values must be same for complete compatibility. Otherwise, it is must to apply casting. It is must to implement type compatibility in C++ language to support the concept of function overloading, in which two functions have the same name but they differ in terms of signature. That is, they differ in terms of types of function arguments. Example, in C language, size of in bracket x is equivalent to size of int. In C++ language, size of x is equivalent to size of char. Now let us summarize the module. Identifiers mainly refer to the names of the variables, arrays, functions and classes, etc. C++ supports various types of literal constants which are characters, integer, floating points and strings. C++ language also identifies all the backslash character as constants. The data types are those keywords which confirm what type of variables that are going to declare. The various data types provided by C++ are built-in data types, derived data types and user-defined data types. Built-in data types that are supported by C++ are integer, floating point and void. The two more data types that are introduced in ANSI C++ are boolean and wchar_t. The character data type occupies 1 byte of data. The integer is a keyword which consists of integer data types in C++. The float is a keyword which is used to represent the floating point data. The double data type stores floating point numbers with much larger range and accuracy. The void data type is an empty type. The boolean data type is mostly used for conveying the result of the logical operations. The void characters are used to hold large character sets associated with some non-English language. The data types that are derived from the built-in data types are known as derived data types. The derived data types are arrays, function, references and pointers. Array is a collection of homogeneous elements. In C++, every program contains one or more functions that can be invoked from other parts of the program. In C++, it is possible to use the same function name with various definition, which is basically called as function overloading. Pointers are used in C++ for memory management and for the purpose of polymorphism. A pointer is declared like a normal variable which is preceded by the star operator. A generic pointer or the void pointer can be allocated the pointer value of any basic data type, but it is not possible to dereference it. The referencing operator ampersand is used to define the reference variable. The structures in C++ are a collection of heterogeneous data type variables which are grouped under one name. The union in C++ is a user defined data type. The elements of anonymous union can be accessed without using the tag name. A class is a collection of data and functions under one reference name. The object is an instance of a class. The values of enumerated data type can be used in indexing the expression. The main use of enumerated data type is that the program can declare the new data type and define the variables of these data types. The data type representation is machine specific. The constant keyword allows creating type constants instead of using hash define. It is a must to implement the type compatibility in C++ language to support the concept of function overloading, in which the two functions have the same name but they differ in the list of arguments.